Okay, so in this example we have, a true binomial setup with a limit or two limits sometimes, particular n and p. Alright, first we'll check whether the normal approximation will work, or it satisfies the conditions. Alright, so first n in this case 150, which is greater than our 50, so that condition holds. And the second condition, the mean, if you like, the expected value of x or mu is n times p is 150 times the p of 0.3, and if I'm doing that correctly in my head, that's 45, which is clearly greater than 5, so both conditions hold. Alright, both conditions must hold, not just one. Alright, so the normal approximation is good. Alright, and then we can go ahead. So, first I'll just write down the same statement as above. Because it turns out that for most of these examples, it's better to write the binomial with two limits, because we'll need those two limits for the normal. Alright, so for the binomial, you cannot have anything less than 0. Sorry, I'm trying to make that equal sign show up better. Alright, so these would be the two limits for the binomial. Okay, so if it, in this case, less than or equal to 40 means 0, 1, 2, 3, etc. through 40. Alright, so on the normal, let's talk about those limits first. So we can think of 41 little bars which we're going to put boxes around. So from 0, 1, 2, 3 all the way through 40, there are 40 different containers. Alright, the first bar around 0 starts at -0.5 and goes to +0.5. The next one will go from +0.5 to 1.5, etc. And that equal sign is not necessary at that point when we go to the normal. And the top bar will go from 39.5 to 40.5. Okay. So those are the limits we're going to use on the normal. Alright, so this is a binomial, this is normal. But when we're talking about the normal, we need a mean and standard deviation. The mean was done up here, right? So 45. And we need a standard deviation, and I haven't talked about the standard deviation yet. Alright, so here it is. The formula for the standard deviation, sigma, little sigma is the square root of npq, or np times 1 minus p. Okay. So in this case, that will be the square root of 150 times 0.3 times 0.7. Let's quickly do that calculation in Excel. So it'll be the square root of n 150 times p 0.3 times 1 minus p 0.7. Alright, and I get a value of, to 4 significant places, 5.612. Okay, so back to our statement involving the normal distribution. Alright, so we now have a normal distribution problem with two limits, a mean and a standard deviation. At this point, it's no different than our other normal distribution examples that we've seen in the previous lecture video. And so what we reasonably do is to draw a diagram. sort of help us visualize the area. So we have a mean of 45, upper limit was 40.5, which is below that, lower limit minus a half, and the one of the limits is quite often a long way away. Alright, we're going to translate those values to the z-distribution and find the limits corresponding to the negative 0.5 and the 40.5. Alright, so we'll use our old formula. Z is x minus mu on sigma. First limit minus a half minus the mean of 45 divided by the standard deviation. Okay, so that'll be minus 0.5 minus 45 divided by, that's standard deviation, with minus 8.11. And as I said, usually we have one limit that's a long way away. The 8.11, if you remember, is off the chart of the normal distribution. And for the second limit, 40.5 minus 45 divided by the standard deviation. Minus 40.5 minus 45 divided by standard deviation. And what did I do wrong? Oh, what I did wrong was it's not minus 40.5, right? The formula like there was 40.5 minus 45, and there it is, minus 0.80. Okay, so our probability from above is equal to the probability of getting a z from minus 8.11 to minus 0.80. Okay, and since this area is on one side of the mean, first we're going to go all the way from 0 to 8.11. Since that's off the chart, that's a probability of approximately a half. Then we're going to subtract this area out. Okay, so first the area from 0 to 8.11 is a half, minus the area from 0, if you like, to positive 0.80, or from negative 0.80 to 0, whatever is the same thing. Go to our tables, look for the probability at 0.80. Alright, that's 2.881. Hope I said that right, 0.2881, and that's 0.2119 for our probability. Alright, so probability of getting the binomial less than or equal to 40, the 150 trials, probability of success in one trial 0.3 is approximately 0.2119. Okay, and that's the process. Alright, so now let's look at another example. If you feel confident enough to do this example yourself, please go ahead, write this problem down, pause the video, and then look at my answer later. Okay, but right now I'm going to go ahead and do this problem.